Okay, welcome to section 11.3, where we look at inference about two means. And in this case, we are looking at independent samples, okay, or independent sampling. So whatever we do in this section is completely different, or in terms of finding the test statistic and then the confidence interval, it is different from what we did under 11.2, because in this case we are dealing with independent samples. Okay, so it means whatever is sampled, whatever we have in the first sample are not influenced by what we have in the second sample. So we need to treat this differently. So as usual, under this in this chapter, we are using just technology to get our results because it's simpler to do. You just have to understand how to set up your hypothesis and interpret the results. Okay, the rest of software can do for you. So we take the first question. It says, assume that the populations in this test are normally distributed. Yeah, so if this is not assumed and you are doing your own research, you have to find out. Okay, you have to be able to establish that. But if we assume that the populations in the test are normally distributed, then it means the sample are also normally distributed. Alright. So A says test whether mu1 is greater than mu2. So in this section, we don't talk about anything like difference, mean difference. We only talk about strictly the means. So mu1, test whether mu1 is greater than mu2 at alpha equals 0.1. 0.1 level of significance for the given sample data. And then B, construct a 90% confidence interval about mu1 minus mu2. So we have a table where we have our sample mean, our sample 1. Okay, so n, that is the sample size for 1, which is 25, and then the sample mean is 50.2, sample standard deviation 6.4. Then for sample 2, we have 18 sample size, 42 sample mean, 9.9 sample standard deviation. So if we are testing that mu1 is greater than mu2, then writing the hypothesis, the null hypothesis is mu1 equals mu2. Okay, it's always equality. And the alternative hypothesis is mu1 is greater than mu2. That is what we are trying to establish. Then we go to step 2, alpha is 0.1. And then step 3, this is where we find the test statistic and the p-value. So in this very area, what we do is because either if you don't have your raw data, like in this case, we don't have the raw data, so we just go to start. Okay, so you go to start, and then go to tests. Now, in this case, we go to two sample t-test, right? And because you have the summarized value, if you go to start, then you specify x1 up to standard deviation of 2. Okay, standard deviation of sample 2. Sample size of sample 2. Then the next one will be specifying your null hypothesis, alternative hypothesis. In this case, that is greater than mu2. Okay, so it's assumed that mu1 is greater than mu2. Then when you have that done, the next thing is highlight the word no when you see pooled. So pooled, it should be no. Okay, highlight no. And then you calculate. So when you calculate, the first output is 3.08, which is the test statistic, and then the p-value to 4 decimal places is 0.0024. Okay, that gives you the p-value. So if we have these two values, then we can now have our decision rule. So the decision is since the p-value is less than alpha, reject H0. Since the p-value is less than alpha, reject H0. So our conclusion will be that there is sufficient evidence to conclude that mu1 is greater than mu2 at alpha equals 0.1. Okay, so that gives so we are done with A. We go to B. Construct a 90% confidence interval about mu1 minus mu2. So we are using a similar approach. We go to start, go to test. So this is confidence interval. So go to start, go to test. Then we do 2 sample t interval. That is option 0. Okay, 2 sample z interval. Then we highlight start, and then we put in the values. Okay, and then you still select. So you specify the C level, which is 0.9, in this case 90%, and then pooled, you still highlight no. Okay, and then you calculate. So that gives you the interval. Lower bound is 3.667, upper bound is 12.733. Right, and then our conclusion is that we are 99% confident that mu1 minus mu2 lies between 3.667 and 12.733. All right. So that gives you the result for question 1. So we go to question 2, and this reads, a researcher wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. Okay, now the table shows the result for the number of bacteria per cubic foot for both types of rooms. So we have different rooms. So what you can realize is that this sample will be independent. So in sample 1, whatever rooms that are observed in sample 1, which are carpeted rooms, will be independent of the uncarpeted rooms observed in sample 2. So this gives you independent samples. Okay, so that is why this question falls under what we are doing in section 11.3. Okay, then the question goes, do carpeted rooms have more bacteria than uncarpeted rooms at alpha equals 0.05 level of significance? Okay, so I can describe my variables. Right? I can make certain statements. Alright, so I can make certain statements. So let mu1 be equal to the mean bacteria in carpeted rooms, okay, or the mean number of bacteria. And then let mu2 be the mean number of bacteria per cubic foot in uncarpeted rooms. So that if I define it this way, then my null will always have the equality, right? So my null has mu1 equals mu2. Then the alternative, what are we trying to find out? So do carpeted rooms have more bacteria? Okay, so you realize the order. So the question is, do carpeted rooms have more bacteria? So the alternative will be that mu1 is greater than mu2. And then alpha is 0.05. So now to do this, you pause the video, right? And then have the 2 data sets in column 1, L1 and L2 respectively. Okay, so you take your calculator, TI-84, and then in L1, you specify, right? So start, edit, L1, that will be for carpeted rooms, and then L2 will be for uncarpeted rooms. Then when you are done, to find the test statistic and p-value, you go to start, go to tests, then go to 2 sample t test, 2 sum t test, and then you highlight data. Okay, then the list 1 you specify L1, list 2 L2, and then with the freak list you leave them the same. Then you go ahead and give your alternative, so that is greater than mu2. mu1 is greater than mu2, and for pool you highlight no. Okay, and then you calculate. No, calculate, and the first output, which is the test statistic, is 0.96, and then the p-value is 0.1780. 0.1780. Alright, so the decision, it says, so what would our decision be? Now you realize that the p-value is greater than alpha, so we say that since p-value is greater than alpha, do not reject H0. Do not reject H0. And what is our conclusion? There is not sufficient evidence at alpha equals 0.05 to conclude that carpeted rooms have more bacteria than uncarpeted ones. So if you do not reject the H0, it means that there is not sufficient evidence to reject, there is not sufficient evidence to conclude H1. there is not sufficient evidence to conclude H1. Okay. Alright. So question 3 gives us a situation where we have an outcome from a statistical software, right, where they've done hypothesis tests and want to see if we'll be able to determine what was done in there. Okay. So question 3 reads, a physical therapist wanted to know whether the mean step pulse of men was less than the mean step pulse of women. She randomly selected 51 men and 70 women to participate in the study. So you realize already from this sentence, we have independent samples. Now, each subject was required to step up and down onto a 6-inch platform for 3 minutes. The pulse of each subject in beats per minute was then recorded. After the data were entered in Minitab, the following results were obtained. Alright. So we have this data, with this outcome. So the first question goes, state the null and alternative hypothesis. So can we tell what the alternative hypothesis will be in this case? Remember, the null will always have equal to in there. So H0 is given that mu1 equals mu2. But to find the alternative hypothesis, you realize that in the image, now you see where they have T test the last sentence in the image. So T test mu men equals mu women, and then into bracket versus less than. So this sign versus less than gives an indication of what they are trying to do. So it means, because you have less than, then it means mu1 is less than mu2. Okay, mu1 is less than mu2. Then the next question, identify the p-value and state the researcher's conclusion if the level of significance was alpha equals 0.01. So looking carefully in the table, you realize that there is also along the same line that we have, that we're able to tell the alternative hypothesis, we have a certain value p. So p equals 0051, right? And this value gives the p-value. So if alpha equals 0.01, comparing these two values, then we can see that the p-value is less than alpha. So we reject H0. And the conclusion is that there is sufficient evidence at alpha equals 0.01 for the researcher to conclude that the mean step time of men was less than that of women. So the mean step time of men was less than the mean step pulse of men. The mean step pulse of men was less than that of women. Okay. So the C says, what is the 95% confidence interval for the mean difference in pulse rates of men versus women? So you look in the table, the graph, the picture, and you realize that is what is done. So the last but one line, it says 95% CI for mu men minus mu women, and you can see you have negative 10.7 and negative 1.5. So those two values give you the interval, right? So the 95% confidence interval is negative 10.7 and negative 1.5. And our conclusion will be that we are 95% confident that the difference between the mean step pulse of men and women lies between negative 10.7 and 1.5. And this is how we have been concluding or interpreting the confidence interval all this while. But another subtle way you can interpret the confidence interval is we are 95% confident that the mean step pulse of men is between 1.5 and 10.7 beats per minute lower than the mean step pulse of women. Okay, why am I using this here? So this is just, by the way, this is also another way to look at it. You realize that we have mu1 minus mu2, right? So if you subtract two values and then you have negative outcome, it means that the value on the left is smaller than the value on the right. Okay, So another way of interpreting it so that you don't use negative in your answer is that, okay, the mean step pulse of men, if you have negative 1.5, it means the mean step pulse of men is 1.5, whatever the unit is, lower than that of women. And for negative 10.7, then it means it's 10.7 lower. Okay, so that is how conclusions are made. So even when you read reports out there, that is how you see the results. Okay, you see the interpretation. All right. So this ends it for section 11.3. And if you have any question, don't hesitate to get help. Okay, so you can reach out to me or send me an email, or you can still get help from the Math Assistance Center. All right. Thank you.